Hi everyone, in this video we are going to be looking at one of the possible questions from Neco Physics Practical 2022. I actually have two of these questions and we'll be looking through the two of them. This particular practical is on plane mirror, so this is one of them. Let me show you the other type as we go through it. So this is the other type. This has to do with the rotation of mirror through an angle theta. So we're going to start with the other one first, then we'll come back to this and finish up with this. Okay, let me quickly run through the instruction. Now, one of the things that you need to do when carrying out physics practical is to always run through the instructions, then write out a composite table for the given parameters you are asked to measure or record. So by so doing, so that you will not be going back to the questions to look through again. So let's quickly look through this. You are provided with a plane mirror, drawing board, plane sheets, optical pins, and other necessary apparatus. Using the diagram above as a guide, as a guide to perform the experiment. So this is the guide here. 1, you are asked to fix the drawing paper to the drawing board. 2, draw a normal NQ. So this is the normal NQ, okay, to meet AB at the midpoint Q. So this is Q. So I'm drawing this as a normal. This is the outline of the plane mirror AB. Then you are 4, draw a straight line ST through A. So this is the line ST through this point here, A. To meet AB at right angle. So this, it means that this line is at right angles to this. You can clearly see it from here. Measure a distance. AC equals X, which is equal to 1.5 cm. So I'm going to measure a distance from this point to this, 1.5 cm. I think that's the starting point. Then draw a line CQ. So this is CQ to represent an incident ray. Place 2 optical pins, P1 and P2 on CQ. So you see one optical pin will be here, another will be here. Place 2 other, replace the mirror on AB. So I'm going to replace this mirror. Then place 2 other pins, P3 and P4, to be in a straight line with images of P1, P2. So these are the images here, P3 and P4. You have to look through this side to see the images on this side and just put it on a straight line. Then you put your pins here and here. So you record that as P3 and P4. Remove the mirror and the pins. 10. Draw a straight line through the positions P3 and P4 to meet AB at Q. So you are going to draw a straight line through this. This is the straight line to meet this line AB at point Q here. Measure and record angle ACQ. So ACQ is theta 1, and angle CQN, that's theta 2. So you see what we are going to be recording. We are going to record X equals 1.5. We are going to record theta 1, and we are going to record theta 2. Then evaluate X inverse and tan theta. So on our composite table, we are going to have X, a column for S in cm. We're going to have a column for theta 1 in degrees, theta 2 in degrees. Then we have to evaluate this. We have this, and we also have tan theta 2. So we have to repeat the procedure for 4 other values of X equals 2.5 cm, 3.5 cm, 4.5 cm, and 6.7 cm. Tabulate your result. In fact, I already have a table for that. So this is my table for that. So you can see the table. I have this column here. I have X in cm. I have theta in degrees. Theta 1 in degrees, theta 2 in degrees, and I have the evaluation of this. Then I have tan theta. Then after that, we have to plot a graph of tan theta 2 on the vertical axis and S inverse on the horizontal axis. Determine the slope S of the graph. Now, have you seen what I have done? this practical, I will not be carrying out this practical as usual. What I'm going to do is just to find the theory of behind this reflection of a mirror. Then I'll use that to generate my readings. Then we'll plot our graph. So just join me and see how I'm going to carry that out. So I'm going to use this my table. So there's no need for me going back to the questions because I already have what I want. I have written all this out. So I'm going to determine theta 1. This is theta 1. Remember where it is. Then I have theta 2 on this side. Now, the theory behind this is that this angle here is equal to this because this is a straight line and this is straight line. They are parallel to each other. Since they are parallel to each other, this angle here is vertically opposite to this. And again, from the laws of reflection of mirror, this angle here, CQN, that's theta 2, is going to be equal to arrow QN, this angle here. So by knowing that this angle here is equal to this and this is equal to this, what we simply do is to get a line, draw this line, and use our protractor to mark out this angle here, and this angle, which are equal to each other. Then automatically it becomes equal to this. Then we'll measure 1.5 cm from here. Then we'll have 2.5, 3.5, 4.5, and 6.0. So let's carry that out. Now this is my drawing board. Now there are things you need to do to show the examiner that you actually carried out the experiment. Here I have just one optical pin. It's enough for me. I don't need 4 optical pins. Then you can see that I fixed this to this and this with 4 office pins. This is to show that you actually carried out the experiment. Then the next thing you have to do is to get your ruler and take any measurement, any length. Okay, let me take a measurement of let's say 1, 2, this is 1 cm, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm taking a measurement of, okay, let me take it to 8, 9, 10 cm. So I am assuming that my mirror is 10 cm long. My mirror is 10 cm long. Then I am going to draw my TAS on this side. So how do I do that? To get a right angle from there, I put a dot here, place this on top of this, put the 0 mark on top of this, ensure that it is straight, then put it at 90. So this is 90. So once I do this, I'll draw a straight line through this. Just draw into any length. So this shows that this line is perpendicular to this. Then the next thing I have to do is to get the midpoint of this line. Remember that I used 10 cm for this, so the midpoint is going to be at 5 cm. So I have 1, 2, 3, 4, 5. So I have 5 here. Put a dot there. Again, to draw your normal, place the 0 mark on this. Ensure that this is straight on this line. Then you get your 90 here. Then I'll draw this through this. So this is my QN, this is my A, and this is my B. Then we are asked to measure. So after you have done this, the next thing you have to do is to measure 1.5 cm from A to this point. So I'm going to measure 1.5 cm. So this is going to give me, this is 1.5 here. So once I get 1.5 here, join this to this. So this is C1 and this is X1, 1.5. So the next thing I have to do is to determine this angle here. I can just place this on this. Once I place this on this, ensure that this line is straight on this, and this is on 90. So this angle is, okay, let me read from this side. So if you look at this, So this angle here is, this is 1, 2, 3, 4, 5, 6, 7, 8 degrees. So I'm going to measure 8 degrees from this side also. So I have 5, 6, 7, 6, 7, 8. So I'll put a dot on this. So I'll measure this. This way. So this is one multiplication from this. Okay. Now this angle here is equal to this and also equal to this. So all I have to do is just to measure this angle from here. So this is going to give me, this is 10, 20, 30, 40, 50, 60, 70, 75 degrees. So this angle is 75 degrees. So this is theta 1. So this angle is also set. So I will just come here and record. Theta 1 is 75 degrees. Okay. 0.0. Theta 2 is also 75.0. So these two angles are equal. Then the next thing I have to do, I'll measure 2.5 from here. So from this place, I measure 2.5. So I have 2.5 here. So I'll now come to this place. I'll join this line again to this. So what you have to do is this. You know, you have to place pins here to show that you have already done this. So on the first one, put a pin here at any point. Then go to this. I place a pin here and place another pin here. So for the second one, I'm actually measuring the glance angle. So measure this angle this way. So this angle is going to be, this is 10, 20, 25, 26, 27 degrees. So on this other side, you measure 27. This is 20, 25, 26, 27. Put a dot here, 27 degrees. So I'll join this again. And use your pin. Place this here, place this here, place this here, place this here. So you know we have to get, so this is theta 1. So we have to get this one again, this angle here, theta 1. Then we have to get, okay, so that means I have to put this one this way. So I have to get this other angle here, which is equal to this. So, and that should just be 90 minus, I measured this to be what? 27, right? So from here to here is 27. So from here to here will just be 90 minus 27. So that will give me 63 degrees. So I have 63 degrees. So this is 63.0 degrees. The other side must also be 63.0 degrees. Then the next one is to measure 3.5. Okay, take note that the angle measured here, this angle here is theta 1. Then the angle between the normal and this other angle here. So let me use colored pencil to change. This is theta 2. Again, the angle between this and this is also theta 2. So all the angle measured between the normal and this line is theta 2. The angle measured between this line and this is theta 1. So the next one we have to do is to measure 3.5 cm. So I'm going to measure 3.5 cm from A. Let me see. This is 1, 2, 3.5 here. So I'm going to draw a straight line from here to this point again. Okay, I think this is better by changing the color. So I'll just measure the angle between this and this. That's this angle here. It's going to give me the other angle this way and subtract from 90. So I place this here. It's on the 0 mark. On the 0 mark. Okay. So I have this is 1, this is 10, 10, 20, 30, 35. So that, since I have 35, I'll go to this place and measure 35 again. This is 30 and this is 35 here. So I'll join this line to this. So this angle is another theta 2 and this one is theta 1. So we are measuring this angle. So now I did 35 this way. So the angle is going to be 90 minus 35. That's 55 degrees. So it means that theta 1 is 55.0 degrees. 55.0 degrees. Something that you may want to do is you may want to alter this angle so that they are not actually very the same. You can just reduce this to maybe 54.5 and that way, so that the angles may not be exactly the same. So like this, I can alter this to, let's say, 62.5 degrees, even though you know that they are of the same value, but just try to alter it so that it do not appear as if you are just manipulating your result. So let's go to the next one, 4.5. I think I might have to draw this line a bit downward. So I have 4.5 from point A again. So I have A. Oh, sorry. So this is 1, 2, 3, 4.5 here. So I'll join this again. So I take my protractor, place it on this. Take note of the 0 mark. So this is 10, 20, 30, 40, 1, 2, 3. That's 43 degrees. So I'll do 90. So I have to do 43 this way again. This is 40, 41, 42, 43. So I'll place it on this. So I'll draw this. So you know that this angle here is going to be 90 minus 43. And that gives me 47 degrees. So I have 47 degrees. Here I can put another angle here. Let's say 47.5 degrees. So they are equal angles. So finally we go for 6.0. So I have 1, 2, 3, 4, 5, 6. Okay, it's exactly 6.0. So I have this. So we join this to this. So again, I'll take my protractor, take note of the 0 mark. So this is 10, 20, 30, 40, 50. So it's exactly on 50. So on this way, I'll go this way, 50. So I'll join this. So the other angle definitely is going to be 90 minus 50, that's 40. 40.0. 40.0. So this is my reading. Then don't forget to always put your pins 2 places. Put this, put this, put this, put this. Then go to the other side, put this, put this, put this. Just put it anywhere you wish to put it. And this is C1, C2, C3, C4, and C5. So this is the required table. Now we can evaluate this and tan theta 2. We can evaluate any of these. So let me just evaluate that. So these are the edited value. The next we have to do is to plot the graph of tan theta against S inverse. Okay, so we have to plot the graph at tan theta 2 on the vertical axis and S inverse on the horizontal axis. You have to be very careful because we have to start both graphs from, okay, we are not asked to start it from the origin, so we just plot the graph any which way we want and we get an appropriate scale. So let's look at this. The least value here is 0.839, so I'll take that to 0, and the highest value is 3.732, so I'll take that to 4. So how do I divide this into 4 large spaces so that I can use a whole large crunch of my graph, a whole large space of it? So let's see, if I start from here at 0 on the vertical axis, that is clear enough?
Yes.
Can it be seen?
Yes.
Okay. So I have 0, so I'll take this as 0. Then I push this up to the vertical axis. So this is my X and Y axis. Then here I'm going to put tan theta. Is it clear enough? It's not clear. Now let me try this. Okay, I think this is better. Tan theta, and this is going to be X inverse in per cm. You always have to put your unit. Good. So I have this. So I want to choose an appropriate scale for this. Now I want to use, if I'm using, this is 2 cm, from here to here is 2 cm. If I use 2 cm to 1 unit, I'm going to have 1, 2, 3, 4. That makes it very small. So let's see, if I try 4 cm, I have 1, 2, 3, 4. I think that's large enough. So I have 5. So let's go with 4 cm to 1 unit. So I have 1, 2, 3, 4, and 5. So this occupies a large space on the graph. Then let's go to this other side. So the least value is 0.1, so I take that to 0, and the high is 0.67, so I take that to 7. So I can just choose a scale of 0.1 cm to 0.1 per cm. So let's take the 2 cm rather, 2 cm. So I have 0.1. Let me turn it this way. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So we have all of this. So that fits into the, remember I was supposed to stop at 0.7, but to increase the space of the graph. Now, having gotten this, now on the X inverse axis, on the X inverse axis, please do not write X axis there. What we are plotting is X inverse. You write horizontal axis. We are using a scale of 2 cm to 0.1 per cm. Then on the tan theta 2 axis, we are using a scale of 4 cm to 1 unit. Why am I using unit for this? Because there's no unit for tan theta. Tan theta is just an ordinary number. This is tan theta 2. Now the next thing you have to do is to get the division on each of these smaller lines. Now we are using 4 cm. Now this is, if you count this line, this is 10 and this is 20. So you divide 1 by 20, you get 0.005. So it means that each of this line is 0.005. Sometimes I would like to write it down. So let me write on the vertical as 0.05. Then on the horizontal axis, I have 0.1. This is 0.1. Then I have 10 of it divided by 10. That gives me, so on the horizontal, I have 0.01. Now, why am I doing this? All of this will make it easier for me to be able to take my readings very easily. Now, let's plot the point. Here I have 3.7732 against 0.672. So all I need to do is to look for, on this graph, a number that is close to 3.7. So I'll do 3.732. I'll just subtract it from 3 minus 3. That gives me 0.732. Then I'll divide it by 0.05. Divided by 0.05. That gives me 14.64. So from 3 places, I'm going 14.64 places upward. So this is 10, 11. Okay, let me just go under 0.67. So I know that I'm going 14.64 places upward. Now let me go to 0.67. So this is my 0.6. Now the number that is closer to 0.7 is 0.6. So I have 0.667 minus 0.6. That gives me 0.067 divided by the horizontal division, 0.01. That gives me 6.7. So I'm moving 6.7 places from this. So this is from 0.6. This is 1, 2, 3, 4, 5, 6. So I think I can just put that in the middle and move it upward till I get to 3. So when I get to 3, I am moving 14.6 places over. So this is 10. 1, 2, 3, 4. That's 14.6 in the middle. Put a dot here and circle it. Then we'll go to the next one. So I'll first of all read the horizontal axis, then I'll go to this. I have 0.4. So 0.4 is exactly on this. So I can just read it upward. So that will not give me any problem. Then I have 1.96. So I'm going to subtract 1 from 1.96 because 1 is closer to that. I have 1.963 minus 1. That gives me 0.963 divided by the vertical division 0.05. That gives me 19.26. So from here I'm going to let's say 19.3 places upward. So I'll go from 1 here. I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 19.2. So let's leave it here because it's closer to 19. So I put a dot there. Then the next one is I go for 0.286. So this 0.286 minus 0.2. 0.2 is closer. That gives me 0.086 divided by 0.01. The vertical. So I have 8.6 places. I'm moving 8.6 places from here. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I can put it at the middle. Just put a dot there to remember where you are drawing it upward. Then I go to this place 1.428. So that would be 1.428 minus 1. That gives me 0.428 divided by 0.05. So that gives me 8.56. So I'm going 8.56 places from 1. So remember, this is where I put my, from here, I'm going 8.6 places. So this is 1, 2, 3, 4, 5, 6, 7, 8. And just put it in between. And I'll put a dot there. Then for the next one, I'm going 0.2222, 0.222 against 0.2. So I have 0.222 minus 0.2. That gives me 0.002 divided by 0.01, the horizontal division. That gives me 2.2. So I'm going 2 places from this. So I just count 1, 2. So I put a dot here. Then I have 1.091. So I have 1.091 minus 1. That gives me 0.091 divided by 0.05. So that gives me 1.82. So I'm just going to move 2 places from 1. So this is 1, 1, 2. Put a dot here and draw a circle. Then finally, we have 0.167. 0.167 minus 0.1. So So that gives me 0.067 divided by 0.01. That gives me 6.7. So I'm going 6.7 places from here. So I have 1, 2, 3, 4, 5, 6.7. Let me just place it closer to this, then I'll read it off. Then I have 0.83. So definitely 0.83 will be 0.83 minus 0 here, which is 0.839 divided by 0.05. So I have 0.839 divided by 0.05. So that gives me 16.78. So I'm moving 16.98 places from here. So this is 10, 11, 12, 13, 14, 15, 16. So I'll put a dot here and draw this. Now obviously you can see that from this graph, you see that this one is down and this one. So let me just draw my line of best fit between these three. So this one is off and the other one below is off. So I'll just draw it through this. Then I'm going to have this. So to get the slope, you can draw a line, a large triangle across from any point. Or just work the slope inside this place. So my slope is going to be this. I'm going to read off this point here. So how do I read off this point? This is 3. Obviously, this is going to be 3.5. This is 3. 3.5. So I'll just count the number of lines here. 1, 2, 3, 4, 5, 6, 7. That is 7. Then I'm going to multiply 7 by the vertical division, 0.05. That gives me 0.3 plus, this is 3.5 plus 3.5. So this point here gives me, let me calculate so slow, 3.85 minus, now go to this place and read this off. So this is obviously middle of this, that's 0.5. 0.5 divided by, remember that there is no unit for the vertical as is delta tan theta 2, there's no unit for it, so I'll leave that at that. Then for the horizontal, I have 0.8 minus, so I can read this down, 0.1. The unit is per cm. So that gives me 3.85 minus 0.5. That will be 3.35 divided by 0.8 minus 0.1 will give me 0.7 per cm. So you know when you divide by per cm, it goes up, that gives you cm. So my slope is going to be 3.35 divided by 0.7. That's give me 4.79 cm. Now the interesting thing is this. Now if you look at this, remember the length when we started our practical, the length we used for this was 10, meaning that this was going to be the length of this, half of this was going to be 5. Now actually this is what we have calculated to be 4.79. That is what we have read from our slope. So when I multiply this by 2, I'm supposed to get 10 cm. Now bearing our reading errors and every approximation and others, we have 4.79, which is close to 8. So if I evaluate, let's say AB or K, whatever, is equal to 2 times my slope, that will give me 2 times 4.79. So that will give me 9.57, which is approximately equal to what? 10 cents. You see that from our calculation, we are back to where we started from. So from this experiment, you see that we can determine from the slope the length of the meter rule of the mirror. Now you see that I did not make use of any mirror, but by drawing just a line. So this is approximately equal to 10 cm. Very little errors there and there, here and there, we have this. Now, this I'm trying to show to you why you should not stress yourself trying to do physics practical. You can actually carry out this experiment without straining your eyes, looking through the mirror and placing pins here and there by carrying out this simple experiment. I hope you have gained fully from this and you are fully prepared for this your Neco exam. I will carry out the other experiment in my next video. Thank you for watching this. Do not forget to subscribe to our YouTube channel and also share this video to other people. See you some other time.